Hello and welcome to 101 Code. My name is Muaz Nashawi. If you like our videos, don't forget to comment, like, and subscribe, and turn on the notifications so you can see all the new videos. In this video, we will talk about the second principle of object-oriented programming, which is abstraction. We're gonna see the definition of the abstraction. We're gonna discuss the benefits of using the abstraction principle in our project. We're also gonna see a real-life example in order to understand how the abstraction can be good for our project. So without any further ado, let's get started. So, what is abstraction? Abstraction is the concept of abstraction is based on handling complexity by hiding unnecessary details from the user. That enables the user to implement more complex logic on top of the provided abstraction, without understanding or even thinking about all the hidden complexity. Abstraction deals with object-oriented programming on the design level, while encapsulation deals with object-oriented principles on the security level. We spoke on the last video about the encapsulation, and we said that there is some similarity with abstraction, but each principle of them are dealing with security and hiding information on different level. So let's focus today on the abstraction. In general speaking, abstraction is the concept of hiding your internal operation or internal methods from the user or from anyone who's gonna use your project in order to make your project looks simpler and more readable, and in order also to give the user the time to build on top of your project instead of wasting the time understanding and learning the internal operation and internal methods and how your projects works from inside. This is one of the most important principles on object-oriented, and also if you look at the real world of programming, you will find abstraction everywhere. Imagine yourself, like for example, wanna learn Java, but in order to learn Java, you also need to understand and also need to learn how Java is written in the first place. That's gonna take like a huge time. In order to understand this more, we're gonna use an example of a car. Imagine now that you want to drive a car, and before you can be able to drive the car, you need to understand and learn every part of the car, how it works, how it's combined, what it do, what is the main reason for it to be inside the car. That's gonna take like 100 years from you to understand this more. Instead of that, you only need to know how you can drive the car, how you can apply the brakes, how you can change the speed. This is like the facade. This is like the interface. You only need to know how to interact with the car from the point of view where you're gonna use it from. You don't need to know how the suspension works. You don't need to know how the internal brakes works. So this is the general idea of the abstraction. Our example is a car. We're gonna build a car object or a car project. We have the car class. We have attributes, which is all private, as we said, red color, and minus sign is a private access modifier, and the green color and plus sign is a public access modifier. So the attribute we have is gas, engine oil, brakes oil, and radiator water, and engine started. Things that it must be present in order for the car to work. Now we build this example without implementing the abstraction principle. So in the side of methods, we have start engine, start driving, apply brakes, check if gas available, check if engine oil available, check if brake. As you can see, a lot of methods. And from the point of view of the user, if you want to drive the car, you only need to know about how you start engine, how you start driving, and how you apply brakes. You don't need to understand how inside the start engine works. Like in order for you to start the engine, you need to check if gas available. You need also to check if engine available. But this from your point of view as a user, you don't need to understand this one. Only the programmer who write this class need to understand this one. So the better implementation is when we use the abstraction principle is to hide all the internal methods. Now, as a class, you only need to know about those 3 methods, and the rest of the internal method, you are using it, and you are the only one who will update it as well. Let's see that in IntelliJ code. As we said, we have a car class here. Inside the car, all our attributes, it's private. This has to do with the encapsulation principle. It's also it's all private. And here about the methods, as you can see, we have all the methods. Now we're not implementing the abstraction principle. So as you can see, all our methods are public. If you see check gas, so for example, inside the method start engine, you will find that if check gas is available and check engine is available and blah blah blah, a lot of methods until you can be able to start the engine. So imagine that you need to learn all of this before you can start driving the car. That's gonna take a long time. So, and also here, while you're writing your code, because it's all method, it's public, and as we said, you don't need to know about it, but it's public. Now, if you want to learn about it, as you can see here and from snippets, all the methods are here. So that's also gonna make some complications, and maybe sometimes you find a method and you didn't read the documentation, so you're not gonna be able to understand what to do. Let's now change this example to implement the abstraction principle. As we said, we're gonna keep the start engine as a facade interface, and the start driving because the user gonna use it, and the apply brakes because the user gonna use it. Any other inside internal, we're gonna change it to private. It's still gonna work inside the class, but for the user outside that class, it doesn't need to see it or understand what it does. So now we're changing everything to private here. Now, getting back to our example, now if we put a car dot, as you can see now, it's simpler. I know that I can start engine, start driving, and apply brakes. So, based on that, let's see the benefits of the abstraction in dialogue. First, you hide the internal logic, which will not affect the user experience, and that's, as we said, is good because the user doesn't need to find all this complexity inside your project. You reduce the complexity of the project from the usage aspect and from the user aspect. And worth to mention here, the user is anyone who's going to use your class or application, even if it's another programmer. Imagine like another programmer is working on another aspect and he has to use your class. He also doesn't need to know all of your internal logic, only the things that he's going to communicate, input and output, like what we study in the design patterns. Also, the benefit is allow users who use your project to focus on building a new feature on top of your project instead of spending the effort on learning how it works. We already speak about that. Now the user have more time to develop new features more than like learning how it works. So that's the abstraction in general in object-oriented programming. In next video, we're going to cover the polymorphism and the inheritance in object-oriented programming. Until then, if you like our videos, don't forget to comment, like, and subscribe, and turn on the notifications so you can see all the new videos.